Now we can proceed with implementing a simple booking system. For each flight, we simply need to keep track of who is sitting in each seat. We'll represent the seat allocations using a list of dictionaries. The list will contain one entry for each seat row, and each entry will be a dictionary from seat letter to occupant name. If the seat is unoccupied, it will contain none. We initialize the seating plan in the flight initializer using this fragment. In the first line, we retrieve the seating plan for the aircraft and use tuple unpacking to put the row and seat identifiers into local variables. In the second line, we create a list for the seat allocations. Rather than continually deal with the fact that row indices are 1-based, whereas Python lists are 0-based, we choose to waste one entry at the beginning of the list. This first wasted entry is the single element list containing none. To this single element list, we concatenate another list containing one entry for each real row in the aircraft. This list is constructed by a list comprehension which iterates over the rows object, which is the range of row numbers retrieved from the aircraft in the previous line. We're not actually interested in the row number, since we know it will match up with the list index in the final index, so we discard it by using the dummy underscore variable. The item expression part of the list comprehension is itself a comprehension, specifically a dictionary comprehension. This iterates over each letter for the row and creates a mapping from the single character string to none to indicate an empty seat. We use a list comprehension rather than list replication with the multiplication operator because we want a distinct dictionary object to be created for each row. Here's the code after we put it into the initializer. Before we go further, let's test our code in the REPL. Thanks to the fact that everything is public, we can access implementation details during development, and it's clear enough that we're doing so since the leading underscores remind us what's public and what's not. That's accurate, but not particularly beautiful. Let's try again with pretty print. Perfect. Now we'll add behavior to flight to allocate seats to passengers. To keep this simple, a passenger will simply be a string name. Most of this code is validation of the seat designator and contains some interesting snippets. Methods are functions, so deserve docstrings too. We get the seat letter by using negative indexing into the seat string. We test that the seat letter is valid by checking for membership of seat letters using the in membership testing operator. We extract the row number using string slicing to take all but the last character. We try to convert the row number substring to an integer using the int constructor. If this fails, we catch the value error and in the handler raise a new value error with a more appropriate message payload. We conveniently validate the row number by using the in operator against the rows object, which is a range. We can do this because range objects support the container protocol. We check that the requested seat is unoccupied using an identity test with none. If it's occupied, we raise a value error. If we get this far, everything is in good shape and we can assign the seat. It also contains a bug, but we'll discover that soon enough. Let's try our seat allocator at the REPL. Doing so, we see that we get a type error in allocate seat. Early on in your object-oriented Python career, you're likely to see type error messages like this quite often. The problem has occurred because we forgot to include the self argument in the definition of the allocate seat method. Once we fix that, we can try again. We create our flight object as normal. We then allocate seat 12A. But if we try to allocate seat 12A a second time, we get a value error. Now we allocate 15F and 15E. But if we try to allocate E27, we get a value error because E27 is obviously not a seat. We now allocate 1C and 1D. But if we try to seat Larry Wall in seat DD, we get yet another value error because, of course, DD is not a valid seat. After that, we pretty print to see how things look. The Dutchman is quite lonely there in row 12, so we'd like to move him back to row 15 with the Danes. To do so, we'll need a relocate passenger method.